thank you for joining us today, and we're very happy to have you here. So you've had a very interesting life. Can you tell us a little bit about your journey in terms of how you discovered like different frontier technologies before AI, observed like the evolution of the technologies in Silicon Valley, and how that kind of like shaped your thinking?
Wow, simple question to start. I think I was very lucky to get interested in software when I was, 14 years old. And this was purely by taste. The stories that I had a neighbor who had an Apple II, and I just sat down and figured how could you sort numbers, and started writing code to figure out better ways to sort number, and I was finding it absolutely fascinating. By chance, this became something very important in the world, but that's certainly not something I planned. It was an incredible gateway, first of all, to the software engineering world, but by other relationship, things like Google X or other scientific ventures. So I think, it would be terrible not to admit the incredible chance I had to be at the right place at the right time. Programming computer is incredibly addictive. You probably all know that, because suddenly you have something that allows you to create without the need for anything else. Everything is in front of you, you have the keyboard, and you can create something totally novel. So I think that, for a teenager, that is crazily exciting. There was a fascination with California. I was in Belgium. I was born in Belgium.
That's right.
And California, this was all the symbol of technology, progress, entrepreneurship, and similar. So I think there was a desire in me to find a way to end up working in California. So I would not say that was a deliberate plan, but that was part of it. So the very first time I came to the US was in 1982, where I had written a video game to impress a girlfriend, literally. And that game was pretty good. So I got $1,000 and a plane ticket to go to California. And I was, 19 years old.
Wow.
And got picked by a car in Los Angeles airport and driven to a place in Malibu. So the first place I saw in the US was Malibu, and I was, this is not bad, actually. But, that was short-lived because the game market kind of collapsed. But there was always in the back of my mind, if you want to do technology, you need to be in California. So in early 91, I was offered to co-found a startup in the Bay Area. And this was, I cannot say no to that. Beyond that, if I look at the different jobs I had, it's very serendipitous. I would never describe myself as a person with a career plan or clear targets. If you put too much expectation, in some way it can become paralyzing. So I think it has been a long history of totally at random meeting fascinating people or influential people and catching the wave. The last thing I would say is that I do change my role periodically. I think that for me, one of the key to success was not to do the same thing for too long. And I will do a job for 4 years, but I think that after 4 years, you become less original in your thinking, and you're less motivated also because you kind of reach a comfortable position in that domain. So I think that every 3 or 4 years, what's the next very scary job I could take? And that's what led me to my current job in Google DeepMind.
Wow, that's really fascinating. And before that, you were at Google X, the Moonshot Factory, which is a lot of rapid innovations, sprints. How do you think being in that environment helped hone your skill as a leader, but also kind of shape your mindset for what AI innovation will look like? Sure.
X, among other things, is an incredible lab to figure out how to get humans to innovate. And they tried many things and many things failed. But this is a place which has been very deliberate in exploring the type of culture that will truly bring innovation. And the ability to experiment with that and make mistakes in the way was an incredible gift for me, because it gave me some principle or some mental pattern on how to build a team and evolve a team to get true innovation, not just extrapolation of what is already known, but having people having that spark of, this is bizarre. Let's start poking at it. So I think I was very lucky to have that role and be able to do those experiments. Also working with people who taught a lot about the subject, and including Sergey or Larry. I mean, there's many years of experience on how to bring the best out of people. AI is an obvious one. I think that as we started to see the progress of AI at X, it was obvious that doing an innovation factory or a moonshot factory without taking advantage of what AI is able to do would be doomed. I think that, as I mentioned, we can speak back about kissing frogs.
Yes.
AI is a way to experiment and explore many things very quickly. I mean, I'll take an example. Often projects will not fail because the technology does not work, but because the techno-economics does not make sense. And you're going to do something brilliant, wonderful, that will lose money. Very hard to push in the modern world. You can use AI to, in 10 minutes, look at the techno-economics of something and at least give you some indicator.
Right.
So from the beginning at X, it was pretty clear that not including those types of tools into the workflow would be a terrible mistake. We went through different phases of that at X. I think that we always were very interested by what today we would call optimization problem. And this can be very large numerical exploration to find novel solution. And in some way that's AI. I mean, a lot of AI is that. But also pushing to see how much AI can be used to produce new ideas, or look at different domains and finding unusual intersection, or reading everything that's being published and be able to figure out that's something new and interesting to look at. So I'm not at X anymore, but that continues being a big part of how you reinvent a moonshot factory.
Yes, and I love that too, because oftentimes the study of AI requires you to be very focused in, and it's good to have a reminder to do that experiment, go kiss the next frog. And then at DeepMind now, I think you're taking that experience and you're essentially also helping people get that culture of it is okay to go out and make mistakes and iterate quickly. And something I'm kind of curious about, we talked about kind of crazy experiments that would be fun, kind of to challenge the developer community.
Yeah. I mean, one crazy experiment we started about a year ago was to explore other ways thinking or reasoning could take place. And I think this was inspired by the fact that humans do not think in terms of words. We think and then we're able to explain it in words, but the thinking process itself is something different.
Right.
So I pushed when I joined to get quite a bit of resource looking at really understanding the nature of the reasoning process. And I think we'll see some good surprise on that front. But this was also very risky. I mean, this is the type of things where you have a 20% chance that something will come out of it. So driving the team to be enthusiastic about the investigation while accepting the fact that it's probably going to fail. And you need to create a very specific type of culture where people feel pretty safe about doing this.
Right.
I think that in many companies, if you fail on something, people will use it. So how do you create a culture which is tolerant to, you don't want people to do stupid things, but you want people to do ambitious things. Yes. I mean, I'm certain the venture community is very similar in that thinking at this point.
And I think it's great to take a look at it this way, because sometimes we forget AI innovation is still driven by AI researchers who are still people. They have context and they have desires and interests too. So one of the things I'm also kind of curious about is that with the sense of the researcher, the human being the driver, the inner world also kind of comes out in terms of how they drive or pilot these AI models. And with Gemini kind of like, recently releases like the ability for like multimodal modals to be more performant, faster, less like lower compute. People also kind of may not remember like the magic that happens when you're able to combine all these different inputs together. So I would love to kind of like, some of your thoughts on that.
The multimodal bet that Google did, and that was way before I joined DeepMind, was a very bold bet. Because this was saying we can have all those modality of data, and at the end of the day, being able to handle all that will enrich the model. And this was incredibly hard. But clearly, I mean, if you look back to the reasoning process, we think in terms of images, for instance, or we think in terms of dynamics. So there was a strong conviction that to do something that would really be AGI, you do need to be able to work in all those different modalities, and therefore the multimodal model. But having to be multimodal adds a large burden to the complexity of the model. I mean, you could have a model that can only code, but the Gemini model needs to be able to generate image, do speech-to-speech, understand legal, be able to write code, design good user interface. I mean, it's a lot of various constraints that we're putting on it. So the fact that we see something excellent emerging out of that, there's a bit of a relief, like, yes, this is working.
Yes, I actually do remember reading some of the earlier research last year, where essentially like the training of like image or video models was improving the performance of like other models, and that's like the magic of having all these modalities together.
Oh yeah. I mean, you look at Gemini writing code, right? It's going to write code, will run the application that was written, and will look at the resulting user interface and interaction, which means posing a judgment on visual things which are very human specific.
Yes.
And it works. But if all you do is to be able to understand text, it's going to be a little bit difficult to get a sense of what is a good human experience from a UI standpoint,
because
for instance.
We don't always think about and like, absorb the world in text.
Yes.
Yes.
Yeah. So I think this was a bold bet that was taken by the people who started DeepMind, but I think that was the correct one. And you see even more specialized things like biology. How much is the knowledge of biology helping in other domains? I mean, the story of science is induction, where inductive thinking, where you see things, or looking at anomaly, but often it is transferring from one domain to another. It is the analogous thinking where you take something from biology and you apply it to economics, right?
Right.
So I think that having that very broad set of data is super important.
Yeah, 100%. I do think the merging of modalities also reflects like merging of mindsets.
Yes, absolutely. And I think there's a lot of data we're not using yet that could be valuable there.
Yeah.
So I think, there's always a question of, we're running out of training data. I don't think that's true. I think we just need to be smarter on what is training data.
And it's also very exciting because towards this, vision of like, AGI or general like intelligence, it may be defined differently, but there's definitely different senses that kind of compute into like, the perception layer first. And so I think we're still kind of seeing like the hardware side improve to collect better senses, like world models are improving.
I mean, it's a great mystery, right? I'm not certain we know how we think. We can make stories about it, but I'm not certain we have access to it. So now we can do experiment in thinking.
Yes.
And that's amazing.
There should be a new field called AI psychology.
Oh, I think we're going to learn a lot about humans by looking at how model works.
Yeah. And there's also like this cool synthesis too, because like as AI becomes like more and more part of our daily lives, we start thinking how the AI thinks, and so like we start influencing each other.
Yeah, I mean that's a subject dear to my heart. Which, when you have, I don't know, everybody in this room probably had a few incredibly good mentors in their education or career. That's a gift. You were lucky to have someone like that paying attention to you and investing the time and energy.
Right.
Now we can have AI doing that for people. So we can give to everybody the ability to get mentors which are incredibly competent, can even have a sense of what you understand.
Right.
So that is so exciting to open the door for everybody. So I think that the way AI can make human better is a very interesting subject.
I agree too. I don't think it should be artificial intelligence. It should be augmented at some point.
Yes, I mean, When calculus was invented, I don't think people felt threatened by calculus. It became a new tool which was remarkable to solve a bunch of problems in astronomy or predicting tides that we were not able to predict. I think of AI as that, right? I mean, it's the supercharging for human. I mean, Steve Jobs would have called it the bicycle for the mind or something like that, right? I mean, what can you bring that will really boost what humans are able to do?
Right. So kind of like to wrap it up, because we're at AGI House, what do you think is a quintessential, non-negotiable kind of capacity that the future of AGI will have?
I think empathy for humans. I think that at the end of the day, everything that we do is to fulfill curiosity, and that's one aspect of human nature, but also improve human condition. So I think that having those models, having a very deep sense of what is something that is good for humans is non-negotiable.
I agree, and I'm happy to have people like you leading the forefront for it.
Yep.
Thank you for spending time with us.
Thank you.
Thank you.